Okay, let's measure the aluminum. You can see it's a little longer. Ooh, I gotta open it up all the way here. All right. All right, so do that, and, oh, blurry. It is still blurry, come on. There you go. Between 6 and 7 centimeters, so my first number is 6. And let's see, 6.1, 6.2. It's between 6.2 and 6.3, so my second number is 2. Then the third number, again, you count how many it takes for them to line up. Oh, it looks like this one does. Do you see how this one's lined up exactly with the one above it? And that's the fifth one. So 6.25 is my first one. So let's go. All right, so here's my first square dimension here. Oops. 1.1, 1.2, it looks like exactly 1.3. So to figure that out, we look to see if all of them are matched, and the one that's closest matched is the 10th one. So indeed, it actually is 1.30. So it's a little bit more than the other one, and I marked it. So I'm going to turn it to the side and measure this side, and then have our last measurement. Oh, see that? It's a little different. 1.28. So it looks like the 8th line lines up, right? These lines aren't lining up until the 8th line. You see how this one's lined up nicely? 1.28, which matches the other one. So this interesting one, the aluminum, one of its sides is actually a little bit, there it goes. One of its sides is a little bit bigger than the other one. So this is 0.0625 meters, 0.0130 meters, and 0.0128 meters. And yes, you need that 0 there. Significant digits, you get some data. You have to make sure in each, when you write down your data points, you have the right number of significant digits and you have the precision on there. So this isn't quite correct. The correct way to write it is the following: 0.0625 plus or minus 0.00. Let me see, 5, that's a 5, right? So yeah, 0.1. So it's 1.30, so it's accurate to within this decimal point, so it's 3 zeros, meters. So you read it 0.0625 plus or minus 0.0001 meters. This one, 0.0130 plus or minus 0.0001 meters. And then we have 0.0128 plus or minus 0.0001 meters. So these are called the precisions, uncertainties, whatever you want to know. I'm only making one measurement of each of these. So the uncertainty of the measurement is just the precision of the device. Because I'm not making lots of measurements and taking an average and the standard deviation, I'm taking one measurement and making the precision the uncertainty or the least count. So the least count of this is 0.1 millimeters or 0.0001 meter. So all data that you take, whether it be physics or any other lab, must have the uncertainty with it, or it should. And calculate, when you start to multiply these three things together to form volume, how you found the uncertainty in the volume, that's actually not an easy thing to do, and an entire field of statistics has been created to deal with that. And in your lab theory section, I talk about how to find the uncertainty in the volume when you're multiplying things together. Let's do an example of that.